I'd like to spend a few minutes dealing with the measurement of level by means of pressure. This would be known as hydrostatic level measurement. The idea is that if you were to have a pressure transmitter connected to a tank, that tank can be filled up with a liquid, and that liquid is going to have a downward force, which means that we're going to measure different pressures at different points, or for different levels we can measure different pressures, and that means that we can determine the level itself. Now, one important thing for us is the formula that's going to get used, and that formula says that pressure is going to be equal to rho g h. G is going to be the gravitational force that we are often going to take, and that has a value of 9.81 meters per second square, which I'm often going to go and use. H is the part that can vary. That's going to be the height of the tank that can vary. And the most important thing here is that the density must remain constant. I've gone and put in a value of rho. Now, we usually are going to work with a specific gravity. And that means if I was to take, for example, a liter of water and weigh it, it's going to weigh 1,000 grams or 1 kilogram. If I was to take the same volume of oil and go and weigh it, it's going to weigh 870 grams. So my 1 liter of water is going to have a specific gravity of 1.000. That's my reference. And my oil, which weighs 870 grams, is going to have a specific gravity of 0.87. These are the values that we're going to go and put into the formula to go and do our calculations. As I've just said, it's absolutely crucial that the density remains constant. Otherwise, you are going to measure an irregular pressure. In my part of the world, we like to work in pascals or kilopascals. So in the formula, pressure is equal to rho GH. What you're going to go and find is if H is going to be in millimeters, your answer will be in pascals. And if H is going to be in meters, your answer will be in kilopascals. If you work with any other pressure types, well, it's very easy just to get a calculator or an iPad or converter, and then you can go and change it to a value of your choice. I'd like to do 2 quick calculations just to show you how easy it is. We are working with water. Now, we know that water is going to have a specific gravity of 1.000, and we have a height of 1 meter. So pretty straightforward. Pressure is equal to rho GH. Our specific gravity is going to be 1.000. G I'm going to work with as 9.81 meters per second square, and H is going to be 1 meter. We're working in meters, so the answer is going to be kilopascals, and straight away we can see that the answer is going to be 9.81 kilopascals. So what you would do is you would take your pressure transmitter, apply no pressure to it, and set it up for 4 milliamps if you're working with a 4 to 20 milliamp signal, and then you apply a pressure of 9.81 kilopascals to it, and you go and adjust your span to give you the 20 milliamp reading. Again, if you are working with a 4 to 20 milliamp signal. Here I have a variation. I'm dealing with a liquid which has a specific gravity of 0.8, and the height is now 500 millimeters. Same process. Pressure is equal to rho GH. In this case, my specific gravity is going to be 0.8 multiplied by 9.81 meters per second multiplied by 500. Now remember, I am dealing in millimeters, and so my answer will be in pascals. And if you do go and do the calculation, you're going to get 3,924 pascals. In other words, 3.9 kilopascals. That would be the way to go and do this calculation. If I have a normal pressure transmitter, I can go and put it at that point, and we can take the measurement. If you happen to have a DP cell or a differential pressure transmitter, well, then the low pressure side just needs to be open to atmosphere, which means it's actually going to give you a gauge pressure, and it's going to give you exactly the same measurement. I've often worked in applications where there might be a take-off line out of the tank. Maybe that's going to go to some other type of pump. And the people in the plant will then ask you to not let the zero go below the takeoff of that pump. So one of two things that you can do: you can either put in the pressure transmitter at the bottom, and you can go and calculate your zero value as well as your span value just using the values that you have got. In the case of the zero, pressure is equal to rho GH, and H becomes the new height at which you'd like to have your zero. Or if you don't want to do it that way, there would be another option, and that would be to physically go and move your pressure transmitter to a new location. Go and put the pressure transmitter over there, and now your zero is going to be an actual zero. So it boils down to what you would like to achieve in the plant itself. We've already said that changes in density can affect your calculation. Also, do remember that for very high accuracy applications, you might want to go and compensate for temperature, because there can be variations in the density as a result of changes in the temperature. Foam should not have any effect on your process whatsoever. In conclusion, remember that your instrumentation must be calibrated on a regular basis, and you also want to keep your lines clean and not frozen at all. Thank you so much. I'll see you next time.